Good morning students, just have a look at this formula. We are going to use it for the problems. Already we discussed this formula in the previous class also. Some cases there is a slit separation for the diffraction I am discussing. D small d may be used instead of A. In the interference pattern we use the D for the distance with the two slits, but here only single slit diffraction we have, that we take it as a slit separation or slit width as A. And distance of the first minima from the center is Y, bottom also Y, total 2Y itself is equal to central fringe width. So between the two first minima we will find the central fringe width. May be mentioned in angles if they have to calculate, no, theta plus theta minus theta we need to consider. Total is plus or minus theta we have to take. And in any case of the refractions, if you have taken the problems, during refraction frequency of light do not change. Frequency is related to the colors. Color and frequency same. Apparent values may change, but real color frequency do not change during refraction and reflections. Color of light depends on the frequency but not on wavelength place. V equal to F lambda applicable for all the waves. And the central fringe width formula is beta naught equal to 2 lambda d by A. Maxima, minima conditions. N equal to 1 to 3 we need to consider. Similarly, resolving power of the microscope. Maybe 1.22 lambda by 2n sin theta may be mentioned. This is approximately taken as 1.22 is taken as 1 only in some cases. That is lambda by 2n sin theta. N is a refractive index of the medium. This is a microscope. This is objective lens. Object size or microbe size is delta x we can take, or 2 points on the object are 2 delta x we can take. Theta is called as a semi-conical angle. N is a refractive index of the medium in which the object is kept. The resolving power indicates that more clarity. More resolving power means more clarity. Resolving limit is directly proportional to lambda, and resolving power is inversely proportional to or inversely related to resolving limit. Lesser resolving limit, more resolving power means small separation also seen well cleared. That is related to inversely proportional to lambda. Maximum possibility for the sin theta is one way to take, and n sin theta is called as a numerical aperture. It is just a number n sin theta, and a semi-conical angle is theta. Just both the points. How can you increase the resolving power? Means decrease the resolving limits. That can be done by decreasing wavelength. Okay, other points just go through the theory. I am going to submit later. Next is for the telescope or human eye also, or eye of the animals. We take the same relationship. That light is coming from the distant object, make the angle delta theta near the objective lens or lens of the human eye near the pupil, we call it as the pupil size length is taken as equals to diameter of this objective lens of the telescope is equals to human eye pupil size. They will give you that size approximately 1 centimeter. This delta theta is equals to 1.22 lambda by d, which is also equal to this y by x for large distances. Delta theta is equals to y by x, and resolving power is inversely related to the resolving limit. Y and x, these are the distance by distance units will not be there, but you have to take the units in terms of the delta theta, and that is the radians, is SI net. Resolving power is 1 by radians per radians is equal to d by 1.2 lambda, inversely related to lambda. Generally they will ask is how can resolving power increase, or they may ask you to calculate b, y or x, etc. Next, electron microscope works on the principle of the dual nature of the electrons, which have the wave nature as well as the matter waves. Means they have the particle nature and also wave nature, have the real mass and also travel like waves. The wavelength is inversely proportional to the accelerating voltage, and resolving power is directly proportional to voltage and inversely proportional to lambda. This problem, the formula is important, not lambda. They will ask you in terms of the voltage only. Next, why sound waves diffraction is easy. If the person is standing behind the wall and talks, you can hear that sound. The sound bends around the wall and comes to you. That is because the wavelength of the sound is very large compared to wavelength of the light. And diffraction pattern purpose, the obstacle size must be in the order of the wavelength. Then easily diffraction is possible. More large wavelengths are easily diffracted. So the bending of the wavelengths is light waves is possible for the sound waves. They can bend around and come to you. But you cannot see the person. If you want to see the person, light should bend. But light won't bend unless you keep some reflecting surfaces like mirrors. So obstacle size is in the order of the wavelength is best diffraction you can find. And sound waves diffraction is more observed compared to light waves because wavelength of sound is very large compared to that of light waves. What is the wavelength of the sound? If you take the audible sound limit, frequency of the sound we can hear start from 20 Hz approximately to 20 kilohertz. 20 Hz to 20 kilohertz. Less than 20 Hz called as infrasonics, more than 20 kilohertz called as ultrasonics, not audible to human beings. unless they are small children. Infants can only hear that infrasonics and ultrasonics. The frequency, if you know, means wavelength you can find out from this. V equal to f lambda. Velocity of the sound is in the order of 330 meter per second at 0 degree centigrade approximately, and to 350 or plus little more at higher temperatures, like in summer you may find the velocity increasing to 350 meter per second. V equal to f lambda. Frequencies, what are the frequencies given? Velocity of sound is this value. They will give you the velocity of sound, and you have to calculate the lambda. Lambda equal to V by f. Similarly, if you calculate the light waves purposes, C equal to f lambda you have to use. C is equals to 3 into 10 to the power of 8 meter per second in vacuum. In any other glass etc. denser medium is you have to take V only. V equal to f lambda. Velocity of light is maximum, and same for all colors, means all frequencies in the vacuum. Next, problems from based on the diffraction pattern. Few problems I have to discuss. First, diffraction minima. Question number 47. First diffraction minima due to single slit diffraction is at 30 degrees for lambda equal to 500 angstroms. It is the first diffraction. You have to check a problem carefully whether it is diffraction or interference. Formulas are opposite for the diffraction and interference. This is the minimum formula for the interference, for the diffraction, but it is a maximum formula for the interference. Same thing for this. 2n plus or minus 1 you have taken for the interference, and n value you have taken. You have to be careful with this diffraction factor. N you have taken 1, 2, 3, 4 only. Next is lambda given is 500 angstroms and theta is 30 degrees. You are asked units, you have to be careful here. You are asked to find out in centimeters. Slit width you have to find out. Slit width means A. Answer, delta x, path difference, equal to A sin theta equal to n lambda. A sin theta is equals to n lambda. You are asked to find out A. So what you have is A into sin 30. N is equals to 1. N equal to 1 into lambda is equals to 500 angstroms, 10 to the power of minus 10 meters. Here we have theta is 30. Sin 30 is equals to 1 by 2. Lambda is 500 angstroms, 500 10 to the power of minus 10 meters, and n equal to first dark, first minima. They will call it the second order minima. First, leave that order number. Secondary word. Sorry, secondary word don't consider. Sin 30 is equals to half. So A into 1 by 2. A into 1 by 2 is equals to 500 into 10 to the power of minus 10. So A equal to 500 into 2 is 1000 into 10 to the power of minus 10 meters, which is equals to 10 to the power of minus 7 meters, which is 10 to the power of minus 7 into 1 meter. 1 meter equal to 100 centimeters, means 10 to the power of 2 centimeters. Careful, we are asked to find out in centimeters. This is going to be 10 to the power of minus 5 centimeters is a slit width. Next, 48. In a single slit diffraction, width of the slit is 0.5 centimeters. It is in diffraction, or called as a diffraction. Slit width A equal to 0.5 centimeters. Focal length of the lens F is equals to 40 centimeters, and lambda is 4890 angstroms. Distance of the first dark fringe on screen is dash. Answer is in meters only, they asked. What they are asking here is y asked, the lens focal length f itself will be equal to d, distance of the screen we need to consider y. Sometimes they will ask you what is the distance between the two first dark fringes, means 2y you have to take, that is the central bright fringe it becomes. We don't have the formula for central fringe bright fringe directly, we have the formula for first minima, second like that, and first maximum, second maximum, leaving the center ones. So 2y, they may ask sometimes y, but here they ask is only y. What is the distance of the first minima on the screen from center to this first minima? Between these two total distances, 2y is equals to fringe width we take, but that is not asked here. Diffraction A is, this is a screen, you are asked to find out this y equal to how much? A. D equal to f. Lens I am not drawing here, there is a lens, not nice to mention. Convert everything into SI system. SI units, centimeters, angstroms. So path difference, answer equal to A sin theta equal to n lambda. Your asked is first dark. So n equal to first dark or first minima. And they are asked to find out y, no? So when theta is very small, sin theta is approximately equal to tan theta is equals to y by d. This is a theta. E is equals to n lambda. We are asked to find out y equal to n lambda d by d. In the interference we are taking this a as a d, here we take it as a small d, here a we are using. N is equals to first dark, lambda is 4890 angstroms. This is sodium yellow light. For 4890, 4896 are the 5890, no, okay, not sodium light, sorry. 1 minute. Angstroms is equals to 4890 and 10 to the power of minus 10 meters. A is equals to, sorry, a sodium light is yellow green, right? 5890, 5896. This is not the one. A equal to 0.5 centimeters. 0.5 into 10 to the power of minus 2 means 0. And F is equals to D equal to 40 centimeters. 40 into 10 to the power of minus 2 meters. So the values into this, y equal to n is 1 into lambda 4890 into 10 to the power of minus 10 into d 40 into 10 to the power of minus 2 by a is 0.5 into 10 to the power of minus 2. Calculate this, this becomes equal to 4.100, power cancels, centimeters. This becomes equal to 48 times 8 into 4890 10 to the power of minus 10. This will be approximately 3.9 something you will get into some 10 to the power of minus 5. Approximately given it there, 4 into 10 to the power of minus 5 meters. Please check up the calculations once. This is not 5890, 5896. It's not yellow light, not sodium light. Please you check up that value later. Next problem is 51. And please numbers, this question numbers what I discussed in the previous class, numbers may not be coinciding, you verify the questions numbers once again. These numbers today, numbers are correct only. Previous class numbers only, question numbers only, you need to verify once after getting the material. Next 51. Narrow slit of width 1 millimeters is illuminated by monochromatic light, means single wavelength of wavelength 600 nanometers. The distance between the first minima on either side of the central maxima on a screen at distance of 2 meters is, in this question 51, it is a diffraction. I am writing the data directly. Lambda is 600 nanometers and distance between the first and minima is how much? Distance d. F is equals to 2 meters and slit width A is equals to 1 millimeter, 10 to the power of minus 3 meters. You are asked to find out distance between two first minima. On both sides of the screen, either side of the screen or both sides of screen from center is dash. You have to find out that. That means from center to the first minima, here also center to first minima. Total separation you are asked to find out what is the distance between the two first minima. Distance between the two first minima on either side from center is nothing but equal to central fringe width. As now we have discussed that relationship. Distance between two first minima equal to central fringe width, that is beta naught, equal to 2 into y is 2y, lambda d by d or d by a, that is nothing but equal to 2y relationship, that is beta naught is equals to 2 into lambda is 600 nanometers, 10 to the power of minus 9 meters. This is 600 10 to the power of minus 9 meters. This is 2 meter directly given, 1 millimeter converted to meters, into d is 2 meters by a is 10 to the power of minus 3. 24 hundreds, 10 to the power of minus 9 into 10 to the power of plus 3. 345, which is 24 into 10 to the power of minus 9 plus 5 is minus 4 meters. Answer is given in terms of the millimeters, so convert into meters. Millimeters value is nothing but equal to 10,000 millimeters equal to 1 meter. So 24 this is 24 in 10 to the power of minus 4, 1 meter equal to 10 to the power of 3,000 millimeters, which is 2.4 millimeters is the central fringe width. Next question is 72. This is related to the microscope. The limit of resolution of the microscope is limit of resolution. Microscope limit of resolution is resolution with the air. Resolution with the air is 3 into 10 to the power of minus 6 meters, that is delta x1, 10 to the power of minus 6 meters. When the medium between the air is between the object lens and the object is air. If the system is immersed in the oil of referent x, in oil of mu. Mu refractive index symbol can be taken as n or mu. In these formulas we have taken n. Refractive index n, refractive index Ri of n is equals to 1.5. The resolving limit is how much? Delta, limit of resolution. Equal to how much? This is with the air, this is with the oil of refractive index. What is the relation for the refractive index? Relation is delta x, theta not change, lambda not change means delta x inversely proportional to n. We have the formula, limit of resolution. Delta x is nothing but equal to lambda by 2n sin theta, not resolving power, it is a limit of resolution. That means R, delta x is inversely proportional to n. So delta x2 by delta x1 is nothing but equal to, x2 is for the oil. Better take this as air, this as a oil. So delta x oil by delta x air is inversely proportional to refractive index is nothing but equal to n air by n oil. N air is approximately equal to 1. For vacuum refractive index is 1, for air nearly equal to 1, slightly more than 1. So we take 1 only here, 1 by 1.5. So delta x oil is equals to delta x air by 1.5. 1.5. Delta x air is nothing but equal to 3 into 10 to the power of minus 6 by 1.5. 1.5 into 2 is 3. So 2 into 10 to the power of minus 6 is the limit of resolution. Meters, sometimes they don't give you the units, just take it as the numbers. But here it is given meters. Meters mentioned, here also unit is meters. Just mention, it's not mentioned means the minutes only they may mention, you can use that relation. Next is 73. It is for telescope. Telescope has an aperture of 1.4 meters. Aperture means that opening for the light, that is a convex lens diameter or objective lens diameter called as D. And they may give this as a small d symbol, not capital D. They may give this as capital D also. Careful with the symbols. Symbols are not fixed for this telescope. 1.4 meters. It is very big telescope. The least angular separation for two stars, for which a resolution telescope which can be resolved by the telescope for the light of wavelength lambda is equals to 5600 angstroms. Find the least limit of resolution or resolution limit. That objective points are just resolved. The least angular separation for the two stars, least resolution limit or least angular separation of two stars, any two objects, for long distance objects. If they are very close to each other appears for the naked eye, but if you see with this telescope they appear separated. Two stars. Delta theta equal to how much? Delta theta is nothing but equal to 1.22 lambda by D. You are asking resolving limit, not resolving power. Resolving power of the telescope or microscope is inversely related to the lambda. Less lambda, more resolving power. More diameter of aperture for this telescope, more resolving power. For the microscope, aperture is no way connected. It is only lambda and refractive index and theta relations. There is no theta relation for the telescope. Resolution limit, that is delta theta. You are given terms of the lambda. Sometimes they will ask you what is the distance of the stars when the separation is already known, or if the separation you have to find out when the distance is known. delta theta is nothing but also equal to y by x we can use, but here we are using that delta theta is equals to 1.22 lambda by d, which is equals to 1.22 into lambda is 5600 into 10 to the power of minus 10 by d is 1.4. Calculate this. Approximately this is 0.7. This is going to be 1.2 I am taking. So 2 7s are 2 6s are 2 6 1, and then approximately 8 point you will get a relation, 8 into 5. The answer is 4 something points. You check up the values. 4.88 into 10 to the power of minus 7. S unit of the angle is radians, not in degrees. These are the problems linked to diffraction. In between problems, please work out, or if you have any doubts, you can ask me. I am providing some hints for some problems, but not for all problems. Next part of this topic is, okay, one more thing we have to discuss. Numericals over, some theory points I have to discuss. According to Huygens theory, wave theory, how the wave fronts can be reflected through the prism, through the lens. The diagrams are given in the notes at the end, you just go through that. Whenever the light rays are diverged from the light source, from the candlelight etc. going, means the wave fronts must be spherical wave fronts. If the lenses you are using so that light rays are focused, then the wave fronts will be again spherical wave fronts. Okay, and even if you are a concave mirror, convex mirror you are using, also similar condition you need to consider. And in case if the light rays are parallel light rays coming from the distant stars, long distance objects, if you are taking object distance equal to infinity, light rays you have to take them as parallel light rays, and wave fronts will be plane wave fronts you need to consider. In case if you are taking the light rays passing through the prism do not magnify the waves, it only bends the light rays. You are towards the base always, try to bend towards the base. Light rays are coming like this, you are taking the parallel beam of light rays, means plane wave fronts. Parallel rays means plane wave fronts you have to consider. Then what happens, this is the light rays bend towards the base. Parallel remains parallel only. The image appears to be shifted. When you are seeing from this side, they appear to be coming from here. That means the object is here, means that appears to be shifted, lifted upwards. When you are observing that image what you are seeing appear to be lifted upwards, but there is no change in the sizes if you are seeing from this side. So parallel rays again means what you get is plane wave fronts. Plane wave front becomes equal to plane wave fronts only, remains plane wave fronts only. And if you take a lens, convex lens if you have taken, parallel rays if you have taken before, plane wave fronts are there. Parallel rays, plane wave fronts. But afterwards light rays are focused. This is equals to focal length. And at the instant when the light ray comes, these light rays, these here wavefront parts are traveling less distance. The center one has to travel more distance, so thickness is more here. It takes more time. So these will be coming out fast. So what you get here is wavefront like this. Spherical wavefront you will get. At the first wavefront, what you are getting has a radius of curvature equal to r is radius of wavefront, curvature of the wavefront is equals to focal length of the lens. They will give you the values, you must be able to find out. And if you take the mirrors, concave mirrors also, diagram is given, please go through that. Reflection, refraction of the lights.